Okay, we're live. All right. Let's just not forget translations, okay? Because we're going to talk about this topic in terms of vectors a little bit. So let's just remember the component form of a vector is in the format a comma b. That's not what the topic is on today, but we will be needing to use that, okay? All right. So this is rotations around arbitrary points. Arbitrary just means random points. It's not the origin, so it's arbitrary points. Something random. All right. So let's say you have a problem. This is exactly what it's going to look like. You're on your coordinate grid, or they might just tell you a verbal description of it, and they say, okay, we're going to take points, and I'm going to make this actually in a really easy way to digest by picking points that are like kind of convenient. We're going to rotate around the point 3, 5, okay? So this is not the point we're rotating, this is the point we're rotating around, okay? I'm actually going to be rotating a point 8, 5. All right? So I'm rotating a point around another point. What you guys have done, you rotate around the origin's a point. All right? And I want to rotate this point 90 degrees, actually let's do 270 degrees counterclockwise. Okay?
Wait, 270 degrees?
270 degrees counterclockwise. So you might see a problem like this. You're going to rotate this point, 8, 5. You're going to rotate point A around a fixed point called point P. Okay? And I want to see where A prime would be after a 270 degree counterclockwise rotation. Now, you won't always have it so conveniently placed. I could have made point A somewhere down here, so it's not directly horizontal from it.
Okay.
Okay? But I'm using this so that way we should know what the answer, we can kind of assume what the answer would be. What quadrant do you assume this point would be after I rotated 270 degrees counterclockwise? Can we assume what quadrant it would be in? Remember, you're going the opposite of how the minute hand goes on a clock, so you're going counterclockwise. Tim?
I guess quadrant 3.
So you think it'll end up here somewhere?
Actually, no, wait, quadrant 4.
Oh, here somewhere.
Yeah, down there.
Okay, I assume the same thing. Okay, this is how you do this process. First, you're going to find the vector that describes how you would get from point P to point A. What is that vector? That would get us from point P to point A. In component form. Declan.
5, 0.
5, 0. Okay, so that's going to be our thing that we said we're going to use. 5, 0, because you're just going 5 over in the x and 0 in the y direction. Okay. So first step. Now, actually, at this point, no pun intended, we don't really need point A anymore because we have point P and we have the vector that describes how to get from point P to A. So we don't even need this for the rest of the problem. We kind of summarize this point because I can get back to this point. If I take point P and use that vector, I will get point A. But from now on, we're going to be working with the vector and the point that we're rotating around, which is point P. So far, so good? All right? If you're curious what point A is again, you erased it, you crossed it out, use that vector, get to point A. So now we're actually going to take the vector and apply the 270 degree rotation rule, which I think is absolutely phenomenal, and I love this process.
Oh.
You're going to apply this rule to the vector. Because what does this vector really tell me? This vector is kind of like starts here, goes here, and now I'm going to rotate the vector around the point that I'm rotating around. Okay? So I'm going to rotate this vector, 5, 0. I'm going to apply this rotation rule here to this vector over here in component form. Okay? Do we remember the rule? First, let me hear the rule. Tim, give me the rule for this.
The rule is y negative x.
It is y, negative x. So, when I apply this rule to that vector class, what do you think I should get? Steve?
0, 0, 5.
0, 5?
Yeah, right.
But something needs to be 0, negative 5.
Yeah, that's what I meant. Yeah.
Okay, and sorry, I almost put parentheses around this. We don't want to use that. This is not an operator, this is a vector. It's a vector that's actually been rotated 270 degrees counterclockwise. Okay, great. So if this vector that we originally had would take us from point P to A, this vector will take us from point P to A prime. Pretty good, right?
Now you do the vector to point P.
You know how to apply vectors in either coordinate or component form to points to translate. You're going to use this vector to translate P to where A prime should be. Okay? So all I got to do is go 0 in the y, negative 5, 0 in the x, and negative 5 in the y, to this point here. We're applying it to this point here. Tim, where should be A prime?
3, 0.
3, 0, like right here?
Yeah.
So let's,
Wait, would be?
what do you guys think? Does it look good?
No. Wait.
No?
Yeah.
Yeah.
That makes sense.
Yeah.
Because this one, and remember, for rotation, the rule is that the image and the pre-image must be equidistant from the point of rotation. So this point, 3, 0, how far is that from the point of rotation? You guys can say it out loud.
5.
5 away. How far is A from the point of rotation?
5.
5 still, okay? So A prime and A are both 5 away. Does it look like a 270-degree counterclockwise rotation?
Yeah.
It does. Alright, and there's the process right there.
Is that your answer?
Yeah, so A prime is at 3, 0. That's your answer. You guys want to practice that again?
Yes, please.
Yeah.
Yes.
Okay. Alright, let me pause real quick and I'll set up another problem. Okay, class, so right now you're working on this problem. Now we're taking point B, 7, 8, rotating it around point P, 6, 2. We're rotating at 180 degrees. So let's try to remember the process that we did. This is your little hint here. You won't see this on the test, but there's your hint right there. Okay. So, do we remember our first step here? Our very first step was to isolate the Steal it.
Like you define how far off P is from B, right?
Yeah, but what's the exact thing I said, Madison?
Component form of the vector.
Yes, the component form of the vector is precisely right. Yes. So, Madison, do you know the component form of the vector?
Or component form 1, 6.
What? Yeah, in this form, yeah. What is it?
1, 6.
Oh, 1, 6, okay. 1, 6. Vector, so we're going to use these. Okay? Let's just make sure that's right. It's 1, up 6. Yeah, that's perfect. Okay, now what did we say before? We're going to perform the rotation on the vector. The rule is negative x, negative y. You don't have to swap anything. Madison, you want to tell me what the rotated vector is?
-1, -6.
So 180 degrees later, you get -1, -6, and it's still a vector. It's not an ordered pair, it's still a vector. Okay? And then we're going to take the rotated vector. Now let me just show you how that looks like visually. Our original vector, I'll put it in blue, starts here, goes this way, and points in that direction. Our new vector after rotation, we start in the same spot and go 180 degrees later, somewhere here. So we're expecting it somewhere down in here, somewhere. All right, so I'm going to just take this vector, apply it to our point P, 6, 2. So we're going to apply this to 6, 2, which is 6, P, 6, 2, which is our point P. And that will give us where B prime should be. And that should give us, let's use this arrow here, B prime. So, Declan, what do we think it is?
5, -4.
5, -4. Let's see where 5, -4 is. 5, 1, 2, 3, 4, somewhere down here. So somewhere right over here, which is pretty much where we expected. I know my points are a little off, but that looks pretty good. Let's see if that was done correctly. So -1, -6 is point P. So I'm going -1 in the x direction, so it brings me to 5. -6 brings me to -4. So yeah, 5, -4. That's correct. Okay. And so that's the process for the second time. Any questions?
Oh yeah, wait. I think I get it now. So basically what you do is, once you find like the 180 degrees, like rotated.
Do you want me to explain it, Steeler? I'd appreciate, like, if you have a question on a specific part, I don't want you to run down through the whole thing. Just ask a question on it, or tell me a specific part that you don't understand. Or do you get it? Do you want me to run through it?
Yeah, can you just run through it one more time?
Yeah, run through it. Okay. So I have my point P. Point B, the problem tells you 180 degrees. That's all it says. Here's point B. Here's point P that you're rotating around. You're rotating 180 degrees. Okay. I'm going to ignore point B. I don't need this anymore because I already found the vector that represents it, 1, 6. You go over 1, up 6 to get to point B. So I don't need point B anymore. and then I apply the rotation 180 degrees, which I showed here. Take this vector, put it through 180 degree rotation, find out what my new vector is. It's now -1, -6. That's my rotated vector. You should be thinking in your head, I gotta rotate the vector. So that tells you find the vector, take the vector, rotate the vector, and then apply the vector to the point of rotation. You following? Any questions so far?
Oh, yeah, no, I get it.
I get it.
I think I'm fine.
You followed? Yeah, okay. So you apply the rotated vector to the point of rotation, the point, not point B, point P. Okay, please don't make that mistake, because that's the mistake I made when I was teaching earlier. And then you get your final B prime, which is down here. That's where B prime is at 5, -4, which looks like it was properly rotated around point B. It looks like it.
So you're just subtracting the rotation from
Yeah,
P.
applying this translation to point
that.
P.
You're
So you
just
get add or subtract.
Subtracting 1 and subtracting 6, you get 5 and 4.
Exactly. Okay. We good? All right.